Hello, everyone. Thank you for joining this panel today. I hope you all had a good lunch. This is a panel on AI factories and gigawatt centers, and hopefully we have a, let's say, interactive session. Just a reminder that through the swap card, you can always submit digital questions. So anytime you want to submit questions or so, or also walk up to the mic, you're very welcome. Without further ado, I will introduce my panelists today. So we have Jeannie from Argonne National Lab. She's Deputy Division Director and ALCF Argonne Leadership Computing Facility 4 Project Director. Jason Haga, who's Chief Senior Scientist from AIST, one of the biggest national labs in Japan. Geetika Gupta from Senior Director of Product Management. And Evangelos like Floros, which he is head of the unit for unit infrastructure for the joint EuroHPC joint European undertaking. I am myself, Mohamed Wahib. I work in RIKEN Japan. While I have been a panelist before, I've never been a moderator, so I had to ask someone who has experience, and she said it's easy, just ask uncomfortable questions and make corny jokes. I was like, I can do that. So you have to bear with me today. There's a learning curve. So without further ado, I guess we warm up, start by an open question from each of the panelists to give our opinion, and then from there we move, discussing a variety of topics, and again, we encourage the audience as much as possible to engage. So first, I guess we start with, I guess maybe we can skip that order and start by the order of seating. We start by Geetika. I think every single panelist would like to get their intake on the same question you see written below there, which is, what do you think is the biggest bottleneck for AI factories over, say, the next 5 or so years? Do you think it's just power? Do you think it's the cooling and hardware supply, software efficiency, policy, or talent, or a mix of all of this? With that, so Geetika, if you might want to give us a few words on that.
Okay, thanks, Mohamed. So when I looked, so should I answer the question first?
Yes, if you wish, and
okay.
Yeah, briefly.
So when I looked at the question that Mohamed sent, it almost looked like a trick question because he already had the bottlenecks listed in a priority. Power, hardware supply, software efficiency, cooling, policy, and talent. So I thought that he's already implying some kind of priority.
That's just ChatGPT. No, I'm kidding.
Okay.
I just put them without any order, and it's up to you to decide.
But the point, what it made me think is some of the things over here, like when it comes to power, it's obvious. Like everybody's talking about the power limitation. Like whenever we talk about, okay, do we have enough power to how many GPUs or how much, what's the scale of the data center? The first question is how much power. So because there's like so much emphasis on power being as one of the limiting factor, I feel like that would not, everybody's already trying to solve it. So I don't see that as a bottleneck. Same thing with hardware supply, and for also, everybody's looking into it. The things that take much longer, I would say, like those are the ones which I anticipate as becoming bottlenecks because they cannot be just solved in one day. They are not one-shot answers if we talk about like how LLMs give an answer and promptly. So software efficiency definitely will take time. And I would say that policy also, because whenever there's policy, there's like multiple decisions or multiple opinions and how to get alignment on those data governance, or how do we do secure, or how do we handle privacy? Those are some things which I would say would take longer, and we do see that becoming a bottleneck. Like whenever we are trying to figure out like what should be a data set policy, or how do we acquire? So I would say the bottleneck would be the policy and the talent. Talent is also extremely, because it takes time. It's not possible that somebody can just quickly reorient themselves to adopting AI techniques or to adopting new techniques. So I would say like that, that takes time, and I see policy and talent being the bottleneck. I feel that the others are solvable.
Okay, great. You have a slide. I guess this fits within more or less.
So I have this slide. This is a very common slide. We look at AI being as a layer cake. At the bottom is everything starts with energy and power. And then that energy is used by chips to convert into something which is useful. And those chips, they come together along with the rest of the infrastructure, whether it's networking, whether it's storage, cooling, everything comes together as part of the infrastructure. So that is like the basic like hardware or infrastructure needs. But then models is where the human knowledge and human talent or the edge comes together. And this is again, we are seeing a lot of innovation over here in terms of model architectures, which model architecture is efficient, and what is the best way to do training versus inference. So models, again, will be as good as the infrastructure on which they are running on. And lastly, eventually, how does it translate to actual revenues? And that's where the applications come in, like how the industries are able to make use of all this infrastructure that has been put together. So this is like how we see as pertaining to the topic of the discussion today.
Great. I like how you have it as a holistic view to cover from top to
Yeah.
bottom. Next, basically the same question was Evangelos, like the same question more or less, and it can be within freeform or through your slides as you wish.
No, just freeform. The slides are about you.
Okay.
So I mean, very quickly, memory prices. That's it. That's my problem. That's the biggest problem we have right now. I mean, we're in the perfect storm. It's the worst period to procure systems, to install systems.
Okay.
We're having an enormous amount of headaches. So, apart from the memory thing, it's the supply chain that is important for us. It's causing many problems, many headaches. And then speaking from the point of view of an organization that is part of the Union, is part of the European Commission, the sovereignty is the important part. We related again with the supply chain, how we can become more autonomous in Europe in the next 5 years, the projects, infrastructure projects that we are deploying, to rely less on other regions and to be more sustained. So this is a big challenge for us. And of course, I mean, we're deploying now more bigger systems. Cooling power will always become a very, very relevant problem. For policy, I say no, there is no problem, because I'm coming from this domain, so I need to support my people. So from the policy side, I think Europe is very strong and we're doing quite well.
That's great. Thank you for the answer. You want to go through your slides? Or
so the slides, I just put some slides to remind people, because I don't think everyone knows what is EuroHPC. So we are a European body. We are under the auspices of the Commission, so we are presenting the Commission. We've been created in 2018 with a regulation from the Commission with a mandate essentially to build the European supercomputing infrastructure, to invest on technologies. We are managing funds from European programs for the 3 European programs of this MFF. Digital Europe Program, Horizon Europe, and Correcting Europe facility. We started on the traditional supercomputing domain, but then we moved to AI factories, and then AI gigafactories recently. A lot of quantum, so we have invested in the last year in developing this supercomputing capacity, but also a lot of quantum systems that they are coming online. We can go to the next slide. In terms of AI factories, this was something that it was introduced to our mandate a couple of years ago. So essentially all our efforts and budgets shifted to developing the AI capacity and talent and services across Europe. We have established 19 AI factories across Europe, in which we have established local support services for the national and European industry, and building this capacity around an AI optimized system. So each one of the AI factories will have an AI optimized system to support their activities. On top of that, we have selected so-called 13 AI antennas, countries that they want to collaborate with the AI factories in order also to provide AI services to develop talents in their regions. So this is an ongoing process and project, quite a lot of work there, also in terms of procurements and systems. And then, next slide, the next big step for us is the AI Gigafactories program, which is departing considerably from what we've been doing so far, in which we select partners, hosting entities, supercomputing centers, and together we will build infrastructure. This one is going to be a different thing. This is Europeans' effort to establish big AI facilities that will run on a commercial, on a private funding approach. We will be launching this in the coming weeks after long months of delegations with our governing board in the union. And in this, we are aiming really essentially to buy access time for a commercial offering that we will build with the size of a gigafactory. And we define gigafactory a facility that will provide an equivalent of 75,000 H100 GPUs. This is just a reference point, just to give a feeling of how large these facilities are expected to be. And our role is to commit that we will buy at least 17% of the available capacity that will be offered there. And 17% also will come from the country that will host these AI gigafactories, and the rest will be private investment, management by private business. So this is our best next thing that is coming.
Great. Thank you very much for that. Next is Jason. Again, it's the same question. You can start from it right away or go through your slides. It's up to you.
Okay, yeah, so maybe just a quick, so first of all, thank you very much, Wahib, for inviting me, and really happy to be here. So I think actually, I think everything on that list is super important. I think it's all, they're all bottlenecks, to be honest. But one of the things that that we've been thinking about a little bit at AIST is probably how to orchestrate these AI workflows across heterogeneous, both hardware and software. And I think that's probably one of the biggest issues, because it kind of touches on all these different issues that Wahib has posed here in his question. So for a little bit of context, if we can go to the next slide. So I wanted to talk a little bit about something that we're trying to strategically position ourselves to take advantage of these newer hardware and software, the heterogeneity. And so we've got this new national project called the NAPA project, and it's Next Generation AI Platform Advancement Project. And it's NEDO funded. I should probably quickly say, AIST, for those of you who don't know about AIST, we're a large nationally funded research institute. Our main mission is to do research that supports Japanese industry. So we're slightly different, but we're very similar to, slightly different at least in mission, but we're similar to the DOE labs in the United States. And I should say, I know some of my DOE friends and colleagues are in the audience, and I wanted to shout out quickly to thank them, because they have an AI testbed that they've built out, and I've been, basically picking their brain for ideas, and so I had to thank them for giving us a lot of inspiration on trying to get, and we successfully started this project. So if we go to the next slide. So basically, the idea is that we're going to do kind of a similar thing. We're going to build out an AI testbed. We're going to bring in a lot of these new AI accelerator architectures into this testbed, and then we're partnering with several different Japanese industry partners. It started last November, basically. It's a 5-year project. It's fairly large, about $180 million across 5 years, so we have some money to actually really do something with this. And again, it's funded by this NEDO organization in Japan. And so, I don't think, and so again, the whole idea is that, the AI hardware and software is changing so rapidly, it's really threatening to leave some of the smaller, SMEs, some of the startups, AI startups in Japan behind. So this idea here is to kind of raise some visibility to other architectures and software stacks that are available globally in the world, and perhaps, help promote their use and adoption in Japan. So if we can go to the next slide. So we've got 3 different work packages. The first one is actually the hardware part of it. We're going to pull in, again, like I said, build out an AI testbed. The second work package is improving the resource utilization based on like a performance estimation tool and some benchmarking. And then the third work package is basically developing a highly efficient, highly performant inferencing system on top of this. And so, so that's kind of the context for that. And so I think my last slide. So again, this was just kind of in thinking about this panel and kind of some of the challenges that we think that we can actually help address with this project and with the infrastructure that we're going to build out. The heterogeneous ecosystem of accelerators. So if you think about if you have kind of, different hardware for training, for inference, you could even think of quantum as an accelerator of a certain type. So, how do you kind of manage this ecosystem, all these different hardware and software. So again, this job orchestration, it would be really cool. So a couple weeks ago, I was at a meeting in Baltimore, the TPC meeting, the Trillion Parameter Consortium meeting, and one of the things that kept coming up was how do you orchestrate a job? So for example, it'd be really cool if you could actually have a button that says train model and deploy, right? So you train it, you'd move it to some sort of inferencing architecture, and then it would be available for people to use. And the idea too, how would you perhaps choose the ones that is the most power efficient or the most performant or something. And so really trying to take advantage of the different, the ecosystem that's out there. And so, and then of course the performance evaluation is always a big issue too as well. And so again, we're hoping to try and at least make some progress in this area and have a better understanding. So with that, I'll stop there.
Thank you. Thank you, Jason. I guess we can move to last but not least, Jeannie. Again, what's your take on these points? And
yeah, thanks, Wahib. So when you sent the prompt question, I stopped and I looked at some of the phrasing on the prompt question, and talking about 5 years from now, and riffing off of a few things that my co-panelists have said, maybe we'll have the AI bubble burst and the memory prices will all fall to the point where we will be floating in memory. But so my perspective is more from the setting up the infrastructure side of this. So for me, when you asked this question, it was you have I think supply chain somewhere in here, but you had hardware supply, and that is what from a computer science perspective, you would think of that as the computer science hardware. But from my perspective, the supply chain in setting up the infrastructure, the power infrastructure or the cooling infrastructure, those are definitely current bottlenecks. They are years out in manufacturing, they're years out in setting up, and you can't stand up factories fast enough to manufacture these parts to be able to satisfy the demand in the marketplace today. So from my perspective, some of the biggest bottlenecks in the next 5 years is going to be in setting up those that kind of infrastructure. Geetika's point is well taken, which is, that is what people are currently experiencing. So there are many groups working on solving that problem today. However, from what I am seeing, I don't see a ready solution or an easy solution that will be a silver bullet that will take care of that problem in the marketplace. Now, that could change in the next 2 years. It depends on how much money you throw at the problem. But there's only so fast that you can set up these factories also. So there's going to be, there will be a forcing function there in terms of how fast you can ramp up the supply to be able to keep up with the demand. And then everybody is asking the question, is this demand going to be continuous? Is this going to be sustained over the next 2, 3, 5 years? Or are we right in the middle of a bubble that's just about to blow up? So, so even the people setting up these factories to manufacture and to provide the supply chain for this demand are asking themselves that question, right? So, so from my perspective, that's going to be some of the biggest bottlenecks.
Excellent point. Thank you all for that. I think now we can move to a round of questions. I would like to take your take on a few points. So one question that I have is, I think Evangelos touched a little bit on, which is pre-modern AI, the role of public infrastructure for HPC, and this is an HPC conference and HPC audience, was very clearly defined. It's the resource to advance science, right? Given now that things have changed, and to speak about it frankly, most of the innovation in building systems with respect to scale and pushing, the frontiers is happening in AI private industry, right? So the question would be, how do you see the role of public infrastructure in moving forward in an era where, again, AI private industry is also, building much more than we could? Do you see that public infrastructure for AI, for HPC should position itself to compete with that? Or do you see it can specialize and, take a niche case to still serve science and so? Or do you think it can, act as a complementary, resource that is public and open to everyone? How do you see that going forward? And again, maybe start with Evangelos, because you had a slide or two about partnership and so on.
Yeah, I think this is a very good question. And of course, I mean, for us, it's something that we're very much involved in this kind of actions and decisions. Essentially, I mean, speaking of EuroHPC, we started as a public initiative in the end, gathering together public research centers, supercomputing centers across Europe, trying to work with them together to deploy HPC capacity, traditional supercomputing capacity. The systems that we deployed at these first stages, like Mare 5, Leonardo, Lumi, were general purpose systems, trying to serve all kinds of workloads, applications. That's why they had a mixture of different partitions, and some of the partitions were GPU partitions. So when the AI craziness arrived, and the EU wanted to support AI across Europe and to empower AI users, it was the first resource that the Commission turned to, let's say, repurpose, redistribute in order to support these applications. And this is what has happened initially right now. This is what we're offering. These GPU partitions also happen to be very good for AI workloads. And then we saw that there we were giving resources to all the communities through our access calls. Suddenly, we had to introduce specialized access calls only for AI. So essentially cutting resources from traditional computational science applications in order to give more for SME startups, for more commercial type of applications. And then is where the AI Factories program also was arrived, which again we saw that it was the public centers that they applied for this. And this caused a kind of problem, because this public research supercomputing centers were not used to supporting industry, which was in the end what we're trying to do with AI Factories. So it's a tricky question. We think that the public sector certainly has an important role to play there, but not departing far from the kind of services that they have been offering so far. I don't think the public service should compete or try to compete with commercial offerings. It's a different domain, different industry. They are doing their job. So we need, the way I said, we need to keep these things separated. We're not competing. We're trying to power, to give the first boost to some people to come, to try, to train some models, and then to move to more commercial environments to continue developing services and then using these resources for commercial purposes.
Okay. That's a very well-rounded answer. Jeannie, do you have any perspective on that?
Yeah, so you definitely learned from your moderator friend in asking uncomfortable questions, so start there. So from what I've seen in the past few years, the one thing that comes to mind is that the private sector AI efforts optimize on very different things from what the national labs and research computing centers tend to optimize on. And so from my perspective, when you say should we be going more to them, and I don't know if there is a them and an us anymore. It's all blending in. But the optimization that happens in industry is very different from the optimization that happens in the public sector. And there are fundamental reasons why that is the case. And so I think they each serve a purpose, but there's going to be a lot more need to cross-pollinate. learn from each other. There are things that industry does that we can definitely use and learn from. And then there's so much history in HPC in the way that we've set up our resources that I'm sure industry can learn from. So from my perspective, that partnership model needs to be that give and take of all the things that each side can bring to the table that the other one can learn from.
Okay, I'll be a little frank. So what would you offer the private industries? Why would they be motivated to do that?
So, the HPC systems that we have stood up have been very dense. They're not optimizing, from the little bit that I've seen, they're not optimizing on space because space is cheap and they can just set up a warehouse somewhere and stand up these huge, gigawatt data centers. But at some point you run out of space. At some point you run out of ways in which you can set this up. So that's, again, I'm coming at this completely from an infrastructure side of HPC. In my opinion, there will be that. There will also be, I think, the focus on research computing and scientific computing that the public sector has through public funding it's not particularly of interest unless it's, at the end of the day, industry is they're industry because they're there to make money. So if they don't see the direct application and the direct translation to their bottom line, they have no reason to invest in it. And if they have no reason to invest in it, does that mean that we just stop doing that research? What does that mean for everybody else on the planet if we only go with research that translates to bottom line dollars?
It's a fair point. Thank you. Jason, care to add any?
I mean, the only thing is that I would add is that the grant that the funding agency that we work with, Neto, the whole goal of that is specifically to partner with industry. So it's expected that there is some type of commercial. So to your point, this is. We're a publicly funded research institute, but the goal is to actually translate something into the commercial space. And so the way I like to think about what we're doing is we're kind of lowering the barrier to entry for some of the industry players in Japan, at least. So again, as I mentioned, we're bringing in some of these newer architectures that I think a lot of people in Japan don't know about. And so then this provides an opportunity for some of the people in industry, some of the data center providers and service providers in Japan to come in, test out this. And if it happens to align with what they want to do commercially, then this allows them to go and actually build it out. And so I think it's a unique funding mechanism, which it's really, again, purpose built to actually help have some sort of impact in industry, at least in Japan. So.
Good answer. So Geetika, I left you to the end because I wanted you also to listen to all of these.
Yeah.
You have a unique perspective from the rest of us because being in NVIDIA, you actually engage very much with both sides. So you see the AI, private side, like I said, pushing the edge on building systems with respect to scale and also the pace, right? It's hard to catch that. But you also have been long in NVIDIA, long been working in the HPC space and continue to do. So how, again, do you see moving forward, like from NVIDIA's perspective, how do you see this can work? Like we said, it's competing, it's specializing. How do you see that from NVIDIA's perspective?
No, I see that both the commercial and the government, like the research, HPC sites, they both have a very important role. Number one, the industry is always like revenue driven. So they're working on projects or initiatives which are going to completely short term influence the bottom line. What the HPC community works on is something more long term. And if the public sector has no motivation to work on those, so who's HPC or these supercomputing labs, they have been the ones who've been investing in these long-term projects, otherwise on which the industries have gone and made products out of it. So I would say that HPC sites are extremely important in providing that. You asked, and yes, the industry, especially it's only in this, when we look at the AI side, that's where I see that, yes, the industry is leading in terms of the advancement. But when it comes to the science problems that are being solved, That's not where industry is leading. That's where the HPC community or the scientific community is leading. Then you ask, like, what does the HPC or scientific community provide? I would say they provide the best training ground for the postdocs. I mean, yes, the supercomputing sites, they don't have the best resources, but then that makes the students, they become more creative, they become more resilient. They know, okay, the system will go down. I have to go in and put the cable in myself. If they're going and working in a big industry, they will never even get a chance to see what a data center looks like. But I would say everybody who's worked in a supercomputing lab, they have had a chance to go and look what an actual data center looks like, what the cooling looks like. These are the actual challenges. When you plug in the cable, the pins may get crooked. So those are some of the things, that practical experience. It's like you're training a surgeon. That's what the HPC or supercomputing sites are providing to the industry.
Indeed. It's a very good answer, actually. Thank you very much. By the way, I remind the audience, anytime you have questions, you're very welcome to go to the mics, or in any time, right? You can feel okay to interrupt us or send through the swap card. Yeah, well, we have a question. That's good.
So I'd be interested in the panel's perspective on the synergies between what you need for AI and what you need for HPC, and how does that affect how you architect the data center, and the answer to the question that was posed at the beginning.
Thank you. That was my next question. Thank you. Anybody care to take? If I can iterate the question for the recording, what is unique about the design? I mean, we established that the HPC will exist in a way, and it's important it plays a role. AI privatized, private industry for AI, they also play a role. But then, where do we see the convergence and divergence, basically? Any take on that?
Yeah, I can attempt to answer Nick's question there. So, are they really two separate bins anymore? Isn't everything integrating into your need for your simulations and your need for inference might be within the same exact question you're trying to answer. And so, why the one versus the other? There's probably a lot more intertwined than.
That's a good point. That being said, I mean, to his point also,
Yeah.
gentleman's point, there are, for example, one clear one is precision, for example. HPC has historically, traced high precision because of, requirements for that, while AI industry, has pushed, and if you see the iteration in NVIDIA hardware design, other hardware, we're going lower and lower. So there's yes, a lot of commonalities, but that being said, there's also a little bit of, so how do you think, I mean, that's a question to anyone, how do you think this can be navigated? Yeah, please.
So, I mean, as I said, when we built our traditional supercomputers, we had these nice big partitions with GPUs, some of them 13,000, 12,000. So when we started to try to serve the AI community, I thought that we are on the safe side, they will be impressed with its fantastic resources. And then some of our EU unicorns came back and said, no, this is not the best. Okay, GPUs, but your network and, I mean, SLARM, I have to wait in a queue, and then you have maintenance for a week. What's that? So there are differences.
Doesn't fit in your memory. Yeah.
So when we started working on the AI factories, we put this AI-optimized requirements. So it's a new architecture. First of all, we start with precision. We're not looking so much, don't put so much emphasis on FP64. We need to cater more for the lower precision requirements of the AI workloads. We saw that in terms of network, things got also a bit more complicated. We needed denser networks, interconnect then on the level of GPUs, not just nodes. And the other very important that we saw was the software layer. I mean, traditional HPC, we had SLARM, almost everywhere, and then you have your scientific libraries, maybe a few tools here and there, and that's it, and everyone was happy. And then suddenly people are asking for multi-tenancy, they want isolation, they want vector databases, for their AI workloads. The software layer becoming much more complicated and also more expensive, so it's affecting also the pricing of the systems. That's why we end up having smaller compute capacity, but more software capacity, more software services. People are asking for containers. Everyone is asking for containers. And you cannot build an AI now infrastructure without containerized capabilities. We see then the network Ethernet coming back into provenance because it's not just the latency and bandwidth. It's also the software flexibility and possibility to slice different networks and to provision multi-tenancy in a very fast automated way. We are departing from there. And then the question is how we keep up with the requirements of the HPC community. There are different requirements that they remain. FP64 remains there as a requirement. So I see that there is some kind of departure there. Two parallel works running together. Maybe at some workflows they need to work together. Science is using more and more AI. But right now, I don't see a real convergence in terms of hardware. I think we see requirement for specialized partitions depending on the workload.
Very good point. And to take a thread from that, maybe to the next question. Historically, HPC, I mean, you had to communicate with the public, with politicians, funding agencies, and governments. What sort of necessity or return of investment are they getting? There has historically been benchmarks, top 500 and so, but that's like just a signal you're giving back where you sit like in generation-wise or capability-wise. But the real way you would communicate is scientific achievements, right? Which is a little bit hard to measure, I know, but it was a way to do it, right? You try to communicate what sort of scientific advancements in different areas you can achieve. If you start to see this where HPC, it's hard to draw a line between HPC and AI factories. And HPC moves in that space more, be it that there's a need or this is how it is. Do you see the way we get evaluated and judged by governments and politicians and by the public shifting and changing? So because, for example, if it's so so energy hungry, would they, for example, tell us how much we're getting for that energy we're giving you? Or tell us, I don't know, science per tokens or some other, do you see the metric? Or also this reflects how we also communicate as a community by which we convince stakeholders that this is needed. Do you see that changing with the move to AI factories or it's the same as it was before?
How do you measure scientific output?
Which is a very good question. Let's answer that first.
Historically we've been, the idea is publications and open publications, rising tide raises all boats, kind of an image. Why would that change regardless of what tool you're using to drive the science forward?
I guess, my point was that if private industry is again taking the lead in that, and they report, through different terms like tokens and revenue is a good point, but we don't make money.
Right. I mean, which is why I guess that's why how do you measure your output for industry drivers? That's their revenue and their bottom line.
Yes.
But for us, the scientific community, that's historically been publications and the science output that comes out of any of these massive endeavors. So So
you're saying it's business as usual. Well, that's good news in a way.
Well, in the sense that it's not tokens burnt, because that you could. I mean, I could go through a lot of tokens in a day doing nothing. Right?
There's a word for it. It's called token maxing.
Yeah, token maxing.
So it will all depend on how you're measuring the success, and you can always say science per watt if you're trying to get to those kind of wonky ways of understanding your return on investment, essentially.
Okay. So. Anybody care to add any?
Yeah, I would say we look at impact that the science has made. I think that it should be the measure for how we rather than flops. Flops used to be an easy way, as in the past. These days, it is tokens per second. But again, then whatever we pick as a benchmark, people start gaming.
Yeah.
And then loses its relevance.
Yeah.
And, but when somebody describes the impact of the science that was done, I think like that stays longer. I know it is a lot more difficult to explain it and present it as an elevator pitch. So, but I would still say that, the science impact, like paper publication, again, like if somebody is being measured on the number of papers published, again, people will start gaming.
Right.
Oh, I have so many publications, but what is the quality of that publication? And to measure quality, if we can relate it to an impact that research made, I think like that should be a measure. And I've also noticed when working with the science community is like people who really understand the work that they're doing, they're able to dumb it down so easily to even a 5-year-old. So if the impact is meaningful, it's very easy to convey it also. So I would say the science impact should be a measure. But we don't know like how we can put it down as a single number. I don't have an answer for that.
If I may add, so, I mean, as a policy-driven organization, life before AI was very simple. Politicians knew top 500s, so the requirement was we need 1 exascale system, 2 exascale systems. So the requirement in the procurement was easy. I need 1 exaflop HPL, deliver it or you lose the contract. We achieved it, politicians were happy, hurrah. And then AI came, which complicated things. And then HPL is not relevant. More flops is not relevant. Tokens, it's a bit obscure as a definition. I think what we see now, there is a switch to that the policy is looking into really satisfying end user requirements. And that's why we're looking into what SMEs, startups in Europe are asking for, and we try to incorporate this in the requirements for the AI optimized systems. And the impact assessment is very tricky. We're trying to do right now something similar for our existing first phase of supercomputers. But as discussed, what do you measure and how you assess the quality of this outcome? There are many dimensions that you can look into. But yeah, it's tricky.
Yeah, Jason, please.
Yeah, so I mean, I think, so actually to your point, because as I mentioned, AIST is more focused on trying to support Japanese industry. So it's a little bit less about the science and like the papers, although that's a part of it. So, I think that, and again, there's lots of different metrics, but I think the workforce development aspect so what we're hoping for is when we actually, after building out this infrastructure, then we can help develop workforce, people who have experience with these newer architectures, which then would feed into Japanese industry because the data centers who buy these new architectures would have some workforce to fall back on. And so, I think that's another metric that, at least for us, would be, an extremely important, way to capture, the value of what we're doing. So.
That goes back to, the previous question about research computing and AI computing and like, who would do that? Right? What industry partner is going to be doing that?
That's a good point. Yeah. Excellent. We have a question. Valerie, please.
Yes, thank you.
Sorry for keeping you waiting.
Oh, no. I was interested in everybody's answer to that question, so thank you. So my question has to do with growth and the trend. So we're now in a growth mode in terms of looking at a high demand for AI factories, gigawatt data centers. In 5 years, do you think we'll still be in a growth mode in terms of that demand, or will the demand start to, do you see it as where in 5 years it may start to flatten a bit in terms of that demand? So I welcome your insights on the demand in terms of that growth trend.
Agents are only growing exponentially, right? So as long as we're spawning agents that are spawning other agents that are spawning other agents, the demands. I'm being tongue-in-cheek. Sorry.
So any insights on that? Of
Yeah,
course, it's hard to predict the future, but
I know it is
within
almost,
what you can,
I know. I would say that right now we're seeing growth in one trajectory, but I would say like another 4 years, something else may come up. So this is like just a cycle that something grows fast and then it plateaus and then something else picks up. Just like we were talking about agents, like 2 or 3 years ago, we were talking about LLMs. Then we started talking about reasoning models. Now we're talking about agents. I don't know what we're going to talk about next year. So something or the other keeps coming. And I think like that's what, that's all human brain, I think. So there's a cycle. Right now we are seeing growth in agents, but then a year later, it may be something else. This will always spawn like new industries, I would say.
Very good point.
Yeah.
I have, again, I'm taking a thread from the question. Again, audience are welcome anytime to ask questions, of course. Effectively, like HPC also, in a way, that there's an impact of all this ongoing stuff on AI. That when we say HPC, it's synonymous with large-scale scientific computing. But to an extent, that was a very small subset of science at large, right? Like computational sciences, like strong, areas like molecular dynamics, CFD, climate weather, et cetera. But I mean, I work in a national lab, RIKEN, has a lot of centers, and I was amazed by when the AI thing came to the front, like, I don't know, maybe 80% of the scientists, like, workforce. They work in wet labs, they work in, scientific facilities, but they have not been, well, they use some compute, of course, to do their work, but it was not an integral part. They're not built around, not like astrophysics or climate weather and CFD and MD, molecular dynamics and so on. So in a way, we have all this big rush from scientists that HPC did not historically, have to, interact with. And you have people who go from, I used to run stuff on my laptop to collect results in Jupyter Notebook, to suddenly I have to use a supercomputer or an AI factory to do all my stuff. So that means, of course, more expectations from governments, from people who fund us and agencies, because now you're not serving a subset of science, it's just computational science, you're going beyond that. So how do you see HPC being impacted by that? Is it a positive thing, because that's more work, a bigger role? Do you see it negative in the sense that we're not ready, because HPC has been historically a niche, and Jenny would tell us how hard it is in the leadership facility to just keep up with the demand of those subset of sciences. How do you see that working out? And again, it started, again, from AI, pushing scientists that are not computational scientists that want to, use that. So now HPC is getting bigger and bigger within that science stack. So any views on that?
Yeah, I totally agree. Like, I see that, with this advent of AI, the scientific computing is open to even the theoretical scientist. Previously, when we were talking mostly to the computational scientist, who would be writing applications and running these workloads. And a theoretical scientist would have to pair with somebody to do the work for them. But now when I'm interacting with some of the theoretical scientists, they say, oh yeah, I can interact with these compute resources myself. Now suddenly, the demand on the compute is definitely growing. So I would say that it's a good thing. Maybe, the HPC leaderships can go and say, oh, because of this, now we are able to
demand as well.
Reach to so many researchers. And it's not that researchers are just in the supercomputing sites. There are people who are doing research in institutes which are working on environment. There are people who are working in non-profits. They also are doing some kind of a research, whether it is for materials, whether it is for climate. Now suddenly, but maybe they were not computational savvy. Now they can also make use of these resources.
I had a lovely interaction with a person who does some support work for ETH Zurich, I think. At ISC, I was sitting at a table, and she was sitting opposite me, and I was just asking her, what do you do, etc. And then she said, I support users on our systems, and she said I had this user who had generated 1,000 lines of code using Claude Code or whatever, didn't understand any of it, tried to run it on the HPC system, and it failed. and now they don't know how to debug it, and they're asking us for help. And I was like, it's 1,000 lines of code. Where am I going to start?
Yes, it's like, for us, this is Tuesday, basically, nowadays.
Right.
It's a normal day.
Right.
This
So
happens.
and I was telling her, I was like, do what I do, which is you take Claude Code, go to client and say, fix this, and then you take that and then go to some other tool and say, fix this. But it's been amazing to watch all the non-computational scientists work through and get to that level. But when you have 1,000 lines of code that you don't understand and you're trying to run it and then hand it to someone else and say, debug this, that's, yeah.
So, anybody care to add, or?
Well, for certain, the demand from the traditional computational science will continue to grow. We see that. But we also see that the synergy between AI and traditional computational science are getting stronger. AI supporting, research, experiments, doing things that you were not capable to do, or test new things that you were not capable to do this beforehand. So I think we need to continue investing on the traditional FP64 hardware, but the synergy between AI should not be also underestimated. It will help a lot also the computational science part to produce better results faster.
Makes sense. Good answer. Yes, you have, but
Yeah.
So gentlemen, please, go ahead.
Yeah, so I have a specific niche question. So if you talk about resiliency of all these large data centers, and what I understand is that number of times the way those backup archivals and the way it's being done, it is not being done in such a way that can be restorable, or it can remain sovereign, and possibly more from restoration audits and all that. So what do you think is the direction? Because it's important for us that all those data which is maintained, and it's critical that you should not lose it. So anything being done in that direction? I know some nations have got their sovereign layers and they have got some standards around that, but globally I see a lot of work required, possibly. And any comments on that?
Unsolved problem. It's a data deluge, right? That's the foundation for so much of the AI work that's being done right now. So from my perspective, it's a constant battle to stay ahead of the game there. Others about the data?
I would say, like, what I've heard is, like, the best data compression is store only what is most important, and maybe needs to be some, I know it's not a solved problem, but probably we are seeing, at least, within NVIDIA, and, when we're talking to customers, we are helping them figure out, like, what's the most important data to store and how to store it. That could be one. I do hear that even the prices of the storage is increasing, which means that, everybody is trying to figure out, like, how do we store the data. It is, while I can say that, store only what is important, it takes time to figure out what's important. We see in our own homes, in our own attics, we have, like, so much stuff which we
and
have
2
not-
years from now, what you thought was important today, 2 years from now, it might be a completely different aspect of the same data set that you just dropped on the floor and walked away. So.
Yeah, so possibly AI really figuring it out, that what is critical for us, and then what backup archival, generic format, some layers which can talk to those billions of files. So I think, and that's the area which, I get this, that we should ask some questions in that space, because those are important aspects to be kept in mind.
Absolutely, yeah.
Thank you.
Thanks.
Next question, Anshu?
So this is actually about the previous topic, about the reach of computation expanding to all sorts of domains and so on. I have a major concern even about those who have experience in using computers, and as they resort more and more to relying upon AI agents to do their code, how do you make sure it's not garbage in, garbage out? And then when you're letting people who have no experience writing their codes and just relying upon AI to produce their code, they don't even know how to verify. And so does it even make sense to expand the reach?
So the flip side, though, Anshu, is that they now get to do things that they had no way of doing before. But it may not be verified. No, I completely understand your point, But I think there's like a flip side to it also, which is there's some advantages, there's a bunch of disadvantages. At any given time, which one outweighs the other is what makes it worth it or not worth it.
A very unsatisfactory answer for the simple reason
Thank you. These
that
are the kind of questions we need.
there is a, I mean, there is the question of trust in results.
So
Where does that come in when you have people who aren't trained to question the results they're getting and verify them correctly?
So if I may phrase that as you're asking about cognitive ownership
Yes.
in a way.
Yes.
Okay, but exactly as Jeannie is saying, how do you gatekeep? I mean, what's
You hire a student today. They you have them do stuff. You're inherently trained to check what the student is doing for you. So it's a matter of. I think it's a matter of training people who are using these tools to treat them the same way that they would treat anybody who they first met, they don't trust, and they have to verify. So yeah, your point about verification, very valid.
That's a very important topic, by the way. Thank you. One more question?
Yeah, so Ashik Anjam from University of Leicester. My question is a bit controversial, so please don't mind. So looks like we are having a catch-up game. Okay, so for example, you are trying to justify the role of agents. Do we need HPC or supercomputer to run agents, actually? So, and this is probably the reason most of the training has gone on to, for example, large data centers, and they're not, they're using more or less a throughput-like computing, actually. So HPC was mostly a high performance or a kind of a tightly coupled communications. AI is not that. You could train a model on using simple off-the-shelf computers, actually, as far as there is a decent kind of number of GPUs. So, and what I see is that HPC's existence probably is at stake, because looks like just Intel became irrelevant because they did not realize how AI is going to transform the sector. Probably HPC would be having the same problem, actually, because agents are not high-performance kind of applications, actually. They are just lightweight, small kind of applications that you could run in a distributed fashion, actually. So now if we are saying that, oh, by the way, for the same kind of load, you should still be using supercomputers, probably it's overkilling, actually.
Okay.
So, and as a result, I don't see HPC as it is in 10 years down the line. So you would become either cloud operators or simple normal like Amazon or Azure-like kind of data centers. And when they start providing both high throughput and high performance computing, so that would become much cheaper. And as a result, all these kind of AI factories and gigawatt data centers, probably existence would become very, very difficult, actually, because we are not innovating the scale that we could compete with the kind of transformations that AI is throwing at us. So I would stop here and would like to get your good thoughts.
Thank you. If I can compress that, I guess the question would be if HPC doesn't sustain the historical unique position in which why it's needed and how it's different and differentiating itself, it can be in the risk of being subsumed by other things, which might be good or bad. It depends on what you think. But I guess this is more or less the spirit of the question.
So.
I'll take a stab. So I think, yes, we're talking all about agents, but I think we are completely missing, maybe the question, how we should be talking is, I solved the science problem, and this is how I solved it. Yes, I used a simulation code here, and I used an agent here, I used an AI surrogate here. So lead with, I'm solving a science problem. Agent is a tool that I'm using.
Correct.
Along to automate some portions of the science flow that I was trying to solve. Agent is not what is running or solving the science problem. It's the scientist solving the science problem using the agent as a tool. That's how we should be talking about it.
Your question correctly, you're saying that the high-performance computing systems are not the right platforms to use for all these AI use cases. And I don't disagree with you from that perspective. I think there are better places to run some things than others, right? We have experienced that. Completely agree with you. But on the flip side, what I don't agree with you is that it'll become completely irrelevant because there are still codes, there are still scientific applications, and there's still a scientific need to have that high precision that HPC centers offer. It may not be everybody who runs on our systems today, but it probably is some fraction of them. So maybe in the next 5 to 10 years, we will discover what fraction needs these high-performance computing resources, and they stay where they are, and what fraction could do with lower precision and can get their work done on other platforms that are, that may not be overkill for what they need, and they move off. So there will be this mix of what tools do you need. So going back to what Geetika was saying, you focus on the science problem and then figure out what are the tools you need. So sometimes maybe you need a high precision system to solve the problem, sometimes you don't. Or sometimes you need a mix. Some part of your application needs this and another part needs that, and they go off into different places. So I think one of you had talked about orchestrating as well, and that's how important that will be. And so,
Thank you.
Yeah, thank you.
So we're approaching the end. We have like 30 seconds, basically. It's hard to summarize all this discussion, but what is, at least for me, like from this angle, visible is that there's a lot of discussion that needs to happen, and HPC is in a way at a position that needs to define its role under the light in new conditions. It's not business as usual. It's not just, oh, we had systems, it's different systems, but we just operate in a different way or so. I think it goes deep beyond that. It requires also how we define ourselves, so stakeholders and the society and decision makers and I mean basically everybody involved, how we define our role with private industry, and also dealing with the reality that, as we said, some aspects like it might be hard to, as Anshu was saying, to imagine how science would be conducted in this environment, or it could be also how do we handle the reality that, how do we deal with the reality that, much more science domains are newcomers, and we have to deal with that. And I hope this discussion stays alive. With that, I encourage the audience. You can, even after we move, send discussion on the swap card and share with us. We'll be glad to offline try to respond to that. Thanks again for staying with us and bearing for an hour. I hope I learned a lot from this. I hope you learned a lot, and let's thank the panelists again. Thank you for your time, and thank you for being here.